Okay, so the next thing we're going to review in this review unit is curve sketching. And so the first thing that we want to look at is the fun chart. Okay, so here is our fun chart. Now, I don't think Miss Teagle uses the fun chart, but I know Miss Orr does, and I know I do. So here's our fun chart, and it's going to help us remember all of our justifications. Now, there's a key over here. So the plus sign means positive, the negative sign means negative. The up arrow means increasing, the down arrow stands for decreasing. The upwards U facing is a concave up, and the downwards U is concave down. So there's your key to what all of the symbols mean. So basically, it's a pattern. It goes positive, negative, zero, undefined, increasing, decreasing, max, min, concave up, concave down, point of inflection. Then we do that's our row for F. Now we do our row for F prime. We skip the first three boxes and we start again. Positive, negative, zero, undefined, just like there. Increasing, decreasing, max, min, just like that set. Then we skip we've got our F double prime. We skip all the way to our increasing and we start again. Positive, negative, zero, undefined. So that just helps us if we are looking for where the function is concave up. It is where either the first derivative is increasing or where the second derivative is positive. So you can identify your characteristic on your graph of F that you're looking for, and then you can identify what to be looking for on either the first or the second derivative. Now, couple things to take note of. One of the things that we do when determining increasing, decreasing, concave up, concave down is a sign chart. A sign chart is not a justification for your work. You have to put your answer, your justification in words, okay? So you must answer in words. And the other thing is, words to avoid are things like it and the function, the slope, things that are generic. You need to specify what is it. You need to specify which function are you talking about. You need to specify the slope of which function, okay? So you can take these words and combine them with a specific function, but without a specific function, then they're generic and they won't work. Okay, so let's try some. Here we've got 2/3 x cubed minus x squared minus 4x plus 2. So we're going to do algebra to be able to identify where we are increasing, decreasing, concave up, concave down. Now remember, increasing, decreasing, concave up, concave, or increasing, decreasing, and then any extrema all come from the first derivative of x. So we need to find f prime of x. So we're going to take the derivative of this, which is 2x squared minus 2x minus 4. We want to set it equal to 0. I'm going to divide by 2, so I'm going to have x squared minus x minus 2 is equal to 0. So that's going to be, if I factor x minus 2 and x plus 1 equals 0, so x equals 2 and negative 1. Now, I am going to build a sign chart. I am going to use a sign chart to help me come up with my answers. I just can't rely on that for my justifications. So if I plug in 0, and I always like to plug into the factored form. So if I plug in 0, I get a negative times a positive, which is a negative. That means we are decreasing. If I plug in 3, I get a positive times a positive, which is a positive, so we are increasing. And if I plug in, hold on, I can't plug in 0. Yeah, I can. If I plug in negative 2, I get a negative times a negative, which is a positive, so we're increasing. Now, you can also use your tangency to determine. Remember, if your factors are squared, then your sign change will not occur. Okay, so if there are no squared factors, then you know your signs are going to alternate. Okay, so how are we going to write our answer? We are increasing on negative infinity to negative 1, union 2 to infinity, because f prime of x is positive. Okay, so there's our justification. We are decreasing on negative 1 to 2, because f prime of x is negative. We have a maximum. Okay, now remember, our maximum happens where our first derivative changes from positive to negative. You can kind of see it happening right here. So this is a max, and then here's your min when we change from negative to positive. So we have a max at x equals -1 because f prime of x changes from positive to negative. And then our last one, we have a minimum at x equals +2 because f prime of x changes from negative to positive. Okay, so you've got to put those justifications in there. All right, now we're going to talk about concavity. So if we're looking for concave up and concave down and points of inflection, that all comes from the second derivative. So here's my first. I'm going to now take the second derivative of that, which would be a 4x minus 2. We're going to set that equal to 0. So 4x equals 2, so x is 1/2. Again, I'm going to build a sign chart. So here's my 1/2. I am going to, there is no factored form for this, so I'm going to plug into my 4x minus 2. If I try 0, it's going to be a negative, so we're concave down. If I try 1, 4 minus 2 is positive, so we're going to be concave up. Now, when we change concavity, remember that's the designation of a point of inflection. Okay, so writing our intervals, we're concave up on the interval from 1/2 to infinity. And this time we're going to say because f double prime of x is positive. We're concave down on negative infinity to 1/2, and that's because f double prime of x is negative. And we have a point of inflection at x equals 1/2, and that's because f double prime of x changes sign. You cannot just put that f double prime of x is 0. It has to also change sign. So we're going to put that it changes sign, not that it equals 0. Now, notice that all of my intervals were parentheses. Okay, well, those aren't intervals. All of my intervals were parentheses. On concave up, concave down, your intervals have to be parentheses. You cannot put brackets. On increasing or decreasing, you actually have the option. You could put brackets or you could put parentheses. But because concave up and concave down are parentheses, I always just put parentheses everywhere so that I am consistent and I don't have to think about it. Okay, what do we have going on next? So now we are going to determine increasing, decreasing, and the location of any maximums or minimums. So here's my function. So I need g prime of x, and I'm going to have to use the product rule. So I'm going to have x cubed times, now this is going to require the chain rule, so it'll be e to the 1 over x times the derivative of 1 over x, which is negative 1 over x squared, plus, now I'm going to take the derivative of x cubed, which is 3x squared, times e to the 1 over x. Okay, I'm going to simplify this. X cubed times negative 1 over x squared is going to be a negative x, e to the 1 over x, plus 3x squared, e to the 1 over x. We want to set that equal to 0. Now, when we're dealing with e's, notice that each term has an e to the 1 over x in common. I'm going to pull that out, and I'll have left a negative x plus 3x squared equals 0. Now, we can set each one equal to 0, but e to the negative 1 over x cannot equal 0, so we're not going to get anywhere with that. So if we have 3x squared minus x equals 0, if I pull out an x, that would give me a 3x minus 1 equals 0, which gives me x equals 0 and x equals 1/3. So now we can build our sign chart off of that. So we've got 0 and we have 1/3. Okay, so I'm going to pick a number bigger than 1/3. I'm going to pick 1. I'm going to plug into the factored form. Now remember that this E piece right here is always positive, so it's not going to affect this part right here. So if I plug in 1, I'm going to have a positive times a positive, so this is a positive, so we are increasing. Now, I do not have any squared factors once I factored it, so I know my signs are going to alternate. If you don't like that though, then you're going to have to pick a number smaller than 1/3, so let's say 1/4. So this would be positive, this would be 3/4. 3/4 minus 1 is going to be negative, so we're decreasing. And then at -1, we're going to be negative times negative, so we're back positive, so we're going to be increasing. This at 0 hits a max, and at 1/3, we hit a min. All right, so our answer, we're going to be increasing on negative infinity to 0, union 1/3 to infinity, and it's going to be because f prime of x is positive. We're decreasing in between, so 0 to 1/3, and that's because f prime of x is negative. We said we had a maximum at x equals 0 because f prime of x changes from positive to negative. And then we have a minimum at x equals 1/3 because f prime of x changes negative to positive. All right. So here is just a summary of what all's going on, and I'm not going to go over all of this, but a lot of times it'll ask you for a combination of the two. So if you want to know where it's decreasing and concave down, you need your first derivative to be negative and your second derivative to be negative. So this kind of gives you a chart of all of the different combinations, okay? Now we are going to talk about absolute extrema. What we've been finding have been relative extrema. And so what we're going to find now are absolute extrema. So the extreme value theorem says that if f is continuous on the closed interval a to b, then we can guarantee that x is going to have both a maximum and a minimum value on a and b. And we know that maximum and minimum value is going to be at either the endpoints or the critical points. So the first thing that we need to do, and this is called the candidates test. What we're about to perform. So we've got our function, h of x is equal to x over x squared plus 1. We're on the interval from -2 to 2. So the first thing that we need to do is to find our critical values, which means I need the derivative of this. So remember, derivative is low d high. So it's x squared plus 1 times the derivative of the top, which is 1, minus high d low. So it's going to be x times the derivative of the bottom, which is 2x, over low or low squared, which is going to be x squared plus 1 squared. Now, we have a fraction, so we have to think about the undefined possibilities. The good news is x squared plus 1 will never be 0, so we don't have any undefined possibilities. So we only have our numerator to work with. So that means we're going to have x squared plus 1 minus 2x squared. We want that to be equal to 0, which is going to be negative x squared plus 1 equals 0. So negative x squared is equal to -1. So x is going to be equal to positive -1. So now we've got our critical values. Step 2 is to build a t-chart. In our t-chart, we're going to have our x values, and we're going to come up with our h of x or our y values. Now we start by putting the left endpoint, then we put our critical values, and then we finish it with our right endpoint. And what we're going to do is take these values and plug them back in to our original function. So when I plug in -2, I get -2 over, let's see, -2 squared is 4, 4 plus 1 is 5, so that's a -2/5. When I plug in -1, I get -1 over 1 plus 1 is 2. When I plug +1 in, I'm going to get a +1/2. And when I plug +2 in, I'm going to get a +2/5. So now we've got our y values. We can identify our absolute min and our absolute max. So at -1/2 is going to be our absolute min, and a +1/2 is going to be our absolute max. Third step is actually to write out your answer. So we're going to say the absolute min of, and you're going to give me the value, -1/2 occurs at x equals -1. Then we're going to do the same thing with the absolute max. The absolute max of +1/2 occurs at x equals +1. So that's going to be how you find your absolute max and mins. And it comes up a lot, guys. You have to know how to find your absolute max and mins. There really is no justification in terms of wording. Your justification is going to be your critical values and your t-chart. So that's what they're going to be looking for your justification. All right, that is it on curve. Oh, no, that's not it on curve sketching. We have one more page. Okay, so now we're going to look from a graph. So it says the graph of the derivative of the function f is shown below. Use the graph to answer questions about f on the interval from -4 to 4, and it is also known that f of -1 is 5. So here is a what you have, and this is going to be our f prime graph. So on our, I like the ladder of success as well. So f prime, when we're looking for f prime, we're going to find, or we're going to be looking at our y values. When we're talking about f double prime, we're going to be looking for our slopes. And when we talk about f, we're going to be looking for our area. All right, so for A, find an equation of the tangent line to the graph of f at the point -1, 5. So remember, for a tangent line, we need two things. We need a point and we need a slope. So our point is -1, 5. Our slope is going to be f prime of -1. Since I want f prime, I want the y value at -1. So at -1, the y value is -2. So my tangent line would be y minus 5 is equal to -2 times x plus 1. Okay? B, on what intervals is f both increasing and concave down? So if we're increasing and concave down, okay, so remember, when we're increasing, we want f prime of x to be positive. When we're concave down, now here's where it gets tricky. I'm going to go back to my fun chart. When I'm concave down, I'm going to look at my first derivative because that's what I have. I want my first derivative to be decreasing. So that's where the fun chart comes in handy, is that it tells you what your first derivative does on concavity. So I'm looking for a positive y value and a decreasing function. So that looks like it's this piece right here and then this piece right here. So it looks like, and we're on the interval from -4 to 4, so it's going to be -4 to -3, union, what is that, 2 to 3? And our justification is going to be because f prime of x is both positive and decreasing. So there's my answer, okay? All right, where does f have points of inflection? So let's go back to our sign chart. Points of inflection on the graph of f happen when f prime has maxes and mins. And again, we don't know anything about f double prime, so I'm looking at my justifications on f prime. So our points of inflection happen, what we're looking for is when f prime of x has maxes and mins. So let's go back to our graph. Let's see, there's a minimum right here at -2. There is a maximum right here at +2, and that's about it, okay? So we've got points of inflection at x equals positive and -2 because f prime of x has max or min, and that should be it, okay? All right, then C, oh, I went backwards. So C is list all critical numbers on the graph of F and then classify them as a maximum, minimum, or neither. So critical values, remember your critical numbers are when your F prime of X is equal to 0. So f prime of x is equal to 0 here at -3, here at 1, and here at +3. So my critical numbers are x equals -3, +1, and +3. Okay, now we have to classify them. So our max, remember our max, let me write this out. Our maximum happens when f prime changes from positive to negative, and our minimum happens when f prime of x changes from negative to positive. Now, f prime, remember, are your y values. So you're looking for when your y values go from positive to negative for a max and from negative to positive for a min. So if I look back at my graph, my y values are going from positive to negative, so that guy is a max. Here, they're going from negative to positive, so that guy is a min. And here, they're going from positive to negative, so that guy is a max. Okay, so we're looking at our y values. So we're going to classify, or we're going to put our answers. We have a max at, what were my two values? X equals positive and -3 because f prime of x changes from positive to negative, and we have a min at x equals 1 because f prime of x changes from negative to positive. So that is our answer down there. Okay, that's it for the notes. If you have any questions, come see me. Hopefully this is a pretty easy review over what we did last year. And then next class period, we're going to review some more over curve sketching, so we're going to spend 2 days on it. But come see me if you have any questions. Bye, guys.